All right, everybody, welcome to this snowy day video to review for your benchmark exam tomorrow. It's not going to be long. I'm just going to go through a couple of the core things that are on your test tomorrow, some practice questions, and that's about it. If you have further questions from this video or from any of the review that you've been doing, please contact me. Just shoot me an email, and I'll try and get back to you today. So the first thing that we have to be able to do on our benchmark exam tomorrow is we have to know how to deal with I in a couple of different ways. So one thing that we have to be able to do is essentially multiply out things that include I in it. So a couple big concepts is that I squared is -1. And the reason why is because the square root of -1 is I. So those are two big things that we need to know. Now, a question I could ask you that deals with using I would be something like evaluate 2x plus 5I squared. Something like that. Okay. Notice I have a variable in there. The variable causes it so that you can't just type it in the calculator and get the answer. So as soon as I see something squared, I know that I have this binomial multiplied by itself. So I could either do the boxes, which I know a lot of you still do, which is awesome. What the heck? And you could deal with it using that, or if you want to distribute, you can. So I get 4x squared, 10xi. I always put the I last, and 25i squared. So if I write all that out with combined like terms, I have 4x squared, I have 20 xi's, and I have 25i squared. Now we have to remember that I squared is special. I squared is what we call the sign changer. It changes the sign of whatever it's attached to. So I have 4x squared minus 25. Notice I'm changing the 25 to a minus, plus 20xi. I use the commutative property to put the term with I last. It's just how everybody does it. The next thing you have to be able to do on your test tomorrow is complete a problem that deals with focus and directrix. So one of the things that we know is that the distance from the focus to the vertex is the same from the vertex to the directrix, because a parabola is created as an equal distance from both the point of the focus and the line of the directrix. So when you see the words focus and directrix, so if I have a focus of 1,6 and a directrix of y equals, we'll say 10. Well, what does that tell me? Well, if I draw like a quick sketch, 1,6 would be here, 10 would be up here. So the vertex is somewhere in between those two, meaning that this is going to open up down. Now, I even know what the vertex is. You should too. The vertex is going to be directly in between the point 1,6 and the line 10. So it would be at the point 1,8. Now, that's definitely going to help me once I figure out my answer, because then I can check to see if my answer was right. Now, to determine the equation here, we have to set up a point, which we'll call xy, and find the distance from the focus and set it equal to the distance to the directrix. So in class, I even said, let's simplify this. So we said y minus the directrix is equal to x minus the x value of the focus squared plus y minus the y value of the focus squared. So if we plug in all the stuff we know, the directrix is 10, so I'm going to say y minus 10. The x value of the focus was 1, so I'm going to say x minus 1 squared. And the y value is 6, so I'll say y minus 6 squared. Square both sides to get rid of the radical, because we don't want to see that in our question, right? And then at this point, we have to make a decision. And our decision is, do we multiply out the x minus 1 squared term, or do we leave it as is? Now, if this was a show or work question, I would leave it as is. If this was a multiple choice question, it's going to depend on how the choices are written. Are they written with a parenthesis of x minus 1 squared in it, or are they written with everything multiplied out? So that's your choice once you get to that point. I'm going to leave it with x minus 1 squared because I like having my answer in vertex form, and I could always easily change it later on if we have to just by multiplying it out. So if we multiply out y minus 10 squared, that gives me y squared minus 20y plus 100. Remember, there's a trick there. You just have to double the number to make it the middle value and multiply the number by itself to make it the last number. So let's try it here. Double negative 6 is negative 12. Negative 6 times itself is positive 36. That's where that comes from. Now, if you did all this right, the y squared should be the same on both sides, which means algebraically they cancel. My goal then is to get y by itself. So if I add 12y to the other side and subtract 100 back this way, I wind up getting negative 8y is equal to x minus 1 squared minus 64. Divide everything by negative 8. And we get y equals negative 1/8 x minus 1 squared plus 8. Now, way back at the beginning, we noticed that the vertex was 1/8. Well, in vertex form, it's 1/8. So we're all set. The next thing you have to be able to do on your test is to be able to determine the solution set of a cubic or quartic equation given one of the solutions. So let me just find one real quick here. All right, so the polynomial we're going to look at here is f of x is equal to x cubed minus 2x squared plus 3x. And we're actually going to solve this two different ways. Okay, so if it was just given like this and there was no other information given, try and factor it to solve. And this is a factorable expression. So if I was to factor to solve this, I'd say, well, the factors are x, because there's a GCF, and actually I have a typo here. Let's change this up to negative 15x. Okay, so if we're factoring, we first take out that GCF, then we could go through and factor more. So this becomes minus 5 and minus or plus 3. So my answers or my solutions are negative 3, 0, and 5. Now that would be a perfectly acceptable method of solving, and this was an easy enough one that was factorable. Well, what if it wasn't factorable? Or what if they gave you more information and asked you to do it without factoring? Right? So there's definitely going to be one on your test tomorrow where you can't use factoring to solve. You have to use long division or dividing. So say, for example, they give you the function g of x. So if we give you a quartic polynomial of x to the fourth plus 6x cubed plus x squared minus 24x minus 20, and I tell you that 1, 0 is negative 5. But what does that tell you? Well, if I know that negative 5 is a 0, that means a factor is x plus 5. So that means I could divide this polynomial by x plus 5. Now, if you're watching this video and you're in my accelerated class, you might be saying, why are you not using synthetic division? It's so much easier. I did not show my Regents class synthetic division, so you could do it on your own and get the answer probably way quicker here. but either way, it'll give you the same result. So if we do some division here, I see I'm going to get x cubed, which is x to the 4th, that's good, and 5x cubed. Those subtract, so that gives me x cubed again, and then the x squared comes down. So to get x cubed, that would have an x squared. So I have x cubed plus 5x squared. I'm going to subtract them, so minus 4x squared, and the negative 24x comes down, so I'll put in a minus 4x. Remember, you're subtracting these, so that gives us negative 4x minus 20, which if we make this negative 4, it gives me the same thing twice, so when I subtract, I get a remainder of 0. Good. So what that tells me is that g of x is the two factors x plus 5. 5 look like poopy. And x cubed plus x squared minus 4x minus 4. Now from here we can continue factoring, or I could even give you a second solution. So if I continue factoring here, I have x squared, x plus 1, minus 4, and x plus 1. So that gives me x plus 1, x squared minus 4, and this x plus 5 comes down. It's okay, Zoe. And then if we keep going, we get x plus 2 and x minus 2, giving us the 4 solutions of negative 5, negative 1, negative 2, and 2. Meaning this graph is going to cross the x-axis 4 times. The other things that are on your test that you should look at or look over are all the different parameters and ways of graphing trigonometric functions. I'm not going to go through that on this video. I just gave you a video on that for your last test. So these are kind of like the throwback questions from other chapters. That's why I wanted to go through them here in this video. But again, make sure you know how to find or graph a trig function and find all the different parameters. Best of luck studying. Enjoy your snow day. And like I said, tomorrow, no matter what, you have your benchmark exam.